This video is about applications of exponential growth and decay that involve percentages. Okay, so the first sentence here for any exponential relation, this is just a reminder that A is the initial value, B is what we call the growth factor. If B is a number greater than 1, like 2, 3, 4, 5, 6, 7, and so on, then it's growth. If it's a fraction or a number between 0 and 1, like a decimal, then it's decay. Okay, now in exponential relations, the growth rate or decay rate is often given as a percentage. And so to determine the growth factor or the decay factor, here is what we do. If it's decay, we would do 1 minus whatever the rate is expressed as a decimal, and I'm going to show you what I mean. If it's growth, we would do 1 plus whatever the rate is expressed as a decimal. And again, this is going to make sense when I show you what I mean. So let's look at our first example. There are 800 caribou in a provincial park. The caribou population has been growing, okay, so that's a hint to you, at an annual rate of 2%. Okay, so let's answer these questions. So I hope you can see that the initial value is 800. Hopefully that part makes sense. And now the growth rate is 2%, right? So expressed as a decimal, that's 0.02. And then to find the growth factor, because it's growing, it's going to be 1 plus 0.02. So it's going to be 1 plus 0.02. So it's going to be 1.02. And oftentimes you can just do that in your head. You don't need to write it out. I'm just writing it out to make sure you understand it. Okay, so let's put it together in an equation. We've got y equals, we have our initial value, and then our growth factor is 1.02, and it's to the exponent of x. That's what makes it an exponential equation. Okay, so there's our equation to represent the scenario, and of course then we would use the equation to answer questions about it. Okay, so use the equation to determine the population 35 years from now. So we're going to take our equation. The x represents the years, so we're going to go ahead and we're going to substitute in 35. And we're going to punch that into our calculator. So obviously we would need to use a calculator here. Okay, remember that when we are doing evaluating relations like this, we do our exponent first. So we punch in 1.02 to the exponent 35. And I get a decimal on my calculator. I'm just going to read it to you. It's 1.9998895 and so on. And right away then I'm just going to work backwards here a little bit, and then I'm going to take that number in my calculator and I'm going to multiply it by 800. Okay, and when I do that, I get 1,599.9, if you like. Okay, so of course that rounds to about 1,600, right? So therefore, the population is approximately 1,600 or 1,600 caribou. Okay, let's try another one. Okay, an endangered species of birds has a current population of 4,000. Biologists estimate that the population decreases by 5% each year. Okay, so do your best to actually pause the video and do as much of this as you can based on our previous example, but let's see what you got. Initial value, 4,000. Okay, the decay rate, okay, so it's decaying by 5%. As a decimal, that's 0.05. Okay, so the decay factor, B, is going to be 1 minus 0.05. In other words, B is 0.95. Okay, I'm going to go ahead and write the equation. Y equals 4,000 times 0.95 to the x. Okay, and hopefully that makes sense to you. That one's decreasing, so it should be a fraction or a decimal right here in terms of the b value from what we know. And why don't you go ahead and pause the video and see if you can use the equation by yourself to figure out the number of birds 5 years from now. Okay, so I got 3,095. You can round to the nearest bird, so the population of the birds in 5 years would be about 3,095. Okay, so you're going to go ahead and try some of these.